Aim: to study the phenomenon of electromagnetic induction. Apparatus required for the experiment are as shown. Take a coil and connect it with a galvanometer as shown. Take a strong bar magnet and move its north pole or south pole towards an end of the coil by holding and dragging it. Observe the position of needle of galvanometer. There is a momentary deflection in the galvanometer needle in one direction. This indicates the presence of a current in the coil. The deflection of the galvanometer becomes zero when the motion of the bar magnet stops. Now withdraw the north pole of the magnet away from the coil and observe the deflection in galvanometer. The galvanometer needle now deflects in the opposite side, that is, in left side. Click on Flip the magnet and move south pole of the magnet towards the end B of the coil and observe the deflection in the galvanometer needle. Place the magnet stationary at a point near to the coil. The galvanometer needle deflects towards the right when the coil is moved towards the north pole of the magnet. Similarly, the needle moves towards the left when the coil is moved away. Deflection of galvanometer drops to zero when coil is kept stationary. Now click on Perform the experiment for two coils to observe existence of induced current in a coil due to a change in the current through another coil placed close to it. Connect a coil, coil 1, say of copper wire, with a source, a cell or a battery through a rheostat, an ammeter and a plug key as shown. Connect another coil, coil 2, connected with a galvanometer close to the coil 1 circuit. Plug the key and allow a current to flow through coil 1. Observe the momentary deflections. It stops at the zero mark as soon as the current in coil 1 becomes steady. Change the current through coil 1 by moving the variable slider on the rheostat coil. You can see that the galvanometer connected with coil 2 shows deflection in one direction when current in coil 1 circuit increases, while the deflection in galvanometer needle reverses when the current in coil 1 circuit decreases. Record your observations in the observation table.